The first one is the background. I want to show. I want to talk about traditional views of raindrops, and then how can we learn about scientific view from the traditional one, and then there is a conclusion and future works that I want to do. And firstly, I think most of us think the raindrops should be teardrop-like, but that's because we usually see the teardrop-like drops from different everyday life, and just like this picture, the drop from the mouth of a faucet is just like a teardrop, but this is not rain, and let's take a closer look. Firstly, if a drop goes down from a faucet, it is teardrop-like in the mouth, and then after a short time, it will be flattened in the vertical direction, and after another short time, it will become back to teardrop-like again. And what's the raindrop like? Is it like the teardrop, or like the middle one, just like a flattened ball? So this is my topic, and firstly, let's give. I want to give you a explanation about the phenomenon, and let's consider a drop in the vacuum. From the principle of smallest surface energy, it will be like a ball, and if we give it a perturbation, just like if it is like this, the traditional view of a raindrop, then it will become quickering. Just become this, like this, and after a short time, it will going back to this, and without this sharp corner, then going back and back again. So if we add the air friction, because of the friction, and it will become stable after some time, and it will become back to the spherical shape. But it is not the shape of raindrop, because the raindrop falls from the sky, and it is it is with some velocity, so we have to add the velocity to it. So there is a pressure here, so it will become more or less flattened, and but we don't know what the shape should be. So let's give. So I'll give another analogy. I just see the pebble in along the railway, and I think the pebble have the similar conditions of formation with the raindrop, because it just like that it flies in the water, and after many years friction, it becomes like this, and just like the pebble, the raindrop flies in the air. After after much time, it will become a stable shape, and so so it is more like that. The raindrop will be like this, and but we don't know any any raindrop that like as big as a basketball. So there must be they must be they must be teared off to small ones, just like this picture showed, and so that's my conclusion. The traditional view of raindrop should just be the drops, the water that is put in the top of the droplets. What I mean is, if a droplet has some forces to pull it to the upper place, it will be more like the tear. So we often see this shape, but the raindrop don't have the forces to pull it to the upper place, so it may more like a flattened ball. And I think there is something to do, some other things to do, because the evolution of the raindrops is still not calculated. That's all. Thank you.